In this second part of the video series, we will cover equipment data entry for several of the most common equipment types, including transformers, low voltage breakers, conductors, and maybe we'll get into some relays also. So the first thing we want to do when we want to enter data into the one line is we're going to left mouse double click on the equipment. When we created the one line, everything was just a single left mouse click. Now we're going to left mouse double click. That brings up a dialog box for the equipment. Every dialog box in EasyPower starts off with the Specifications tab. That's the tab that describes the information that you would find on the nameplate of that equipment. So the type is going to tell us for this transformer whether it's oil, gas, silicone, dry type. The class rating is going to tell us whether it's OA, forced oil, air, forced air, and things like that. Temperature rise, we'll pick a standard 55-65. This is all on nameplate data. Now, anytime that we have to have data that's mandatory, we're always going to flag the cell in red, either a red cell or a red dot. So in this case, we need to know what the transformer kVA rating is. So I'll type in 1000 kVA. Now, if I want to figure out what the forced, cooled, or overload rating is, it will calculate that for me if I filled out this information. So as you can see, it's really simple. All we need is the nameplate data. Now, typically there's two tabs for most equipment that we need to fill out data for. The second tab for a transformer is the impedance data. So we need to know what that positive sequence impedance data is, and it's right on the nameplate. It's probably going to be something like 5.75 or 6%. Now, you're never going to find the zero sequence or the X over R ratio for a transformer on the nameplate. They just don't test each and every unit to that degree. So we typically provide a calculate button that will calculate the zero sequence based on a typical core type transformer design and the X over R ratio based on ANSI standards. If we had a high resistance grounded or a low resistance grounded system, we'd just type in the amp class, like a 2 amp for a high R ground. It would calculate the grounding resistance, and then it will morph the graphics as we close the dialog box. Now, these other tabs are for more advanced studies, such as protective device coordination, load tap changers, harmonic stability, and things like that. More advanced than what you'd find in a short circuit or arc flash study. But let's go through them briefly just so you can see that they're not intimidating or anything. We already have all the defaults necessary for the transformer damage curve, such as 100% withstand, plotting unbalanced derating, whether or not we use frequent or infrequent fault curves, the magnetizing inrush, and those types of things. Load tap changers, this just allows us, if we're doing a power flow study, if we want to model the from or the to side with an LTC, controlling the from or the to side, we can control voltage or megavar flow through the transformer, any step size, any tap range. If we were modeling harmonics and doing a harmonic study, we could model the eddy current losses and resistance factor. If we were doing a stability study, we could model the magnetizing inrush for the transformer. Comments, this is just if we want to put notes, dates, maintenance info, things like that. Different facilities may be interested in the hyperlinks command, so we can actually add documents to the one line. We can browse our hard drive and maybe add a file such as a work permit or safety practices. Now, once we do that, now anybody can come in to the program, click on this transformer, and access the work permit or safety practices or oil transformer test reports or any document associated with that transformer. So it provides a great one-stop shopping place to find everything we need to know about that transformer, including instruction manuals. So when I say OK, now here's our transformer. I can actually grab a CT and a relay, and so now we can make a high resistance grounding alarm system. I can double click on this CT, make it a say 10 to 5 unit, one CT. We'll double click on this relay and we'll pick say a General Electric, and we'll pick, say, an old IAC 51 unit, and this will be 1 unit, and it will be a 51 alarm. But when I say OK, now I've got my high resistance grounding system for this transformer. Let's press our little roller. I'm going to move the page up to the secondary main breaker of this switchgear lineup. I'm going to left mouse double click on it, and you can see here is the data entry for this breaker. Now we break low voltage breakers, we break it up into the NEMA UL categories of molded case, insulated case, and low voltage power circuit breakers. In this case we've picked low voltage power circuit breakers, so if I select the manufacturer, it will actually tell us all the different manufacturers that make low voltage power circuit breakers, and this database goes clear back into the 1940s. So if I pick something like a GE and then go to the breaker type, it will show me all the different low voltage power circuit breakers GE has ever made, from the 1940 A series, the 1950 ALs, the 1960 and 70 AKs, the 1980 and 90 AKRs, their new IntelliGuards and Wave Pros, their IEC MPACs. So let's say I pick an AKR series. It will then give me all the different styles, and this is what I really care about, is the style of breaker. Here in this case, here's all the AKRUs. These are the fuse combination. AKRTs, the high capacity H's, the S's, and the L's, they're all here. So if I pick something like an AKR50, watch what happens when I select it. All the manufacturer and types of the solid state trip device are going to change. You'll see that we've got this solid state trip device, GE Microversa Trip PM, low voltage power circuit breakers, the sensor. All I have to do is pick the sensor and the plug rating, and now we have our device. The next question is, would we really want to spend our time filling all that out? Well, the answer is no. So in practical use, what you do is you hit Find Style and you type in AKR. It finds all the AKRs. You pick an AKR50, hit Select, and we're good to go. Now, low voltage power circuit breakers, there's a lot of different tabs up here. We typically only use the first 3 for most studies, but we have a lot of different options in case you want to add other functionality. Short circuit, all we do is hit calculate. That tells us that this breaker is rated for 50 kiloamps. Now the phase trip settings, that's showing us that, hey, once you put a sensor in or a trip device in, we need to know what the settings are. Now if we were doing automated design, the automated design procedure would select all this for us, but now we're assuming that we're actually out collecting field data. So we'll put in the trip devices. Okay. Now if it has a ground trip, we just check plot ground TC and we can put in the trip device. If it had zone selective interlocking, we would just check the ZSI box and we would put in our zone selective interlocking. If it has an integral fuse, such as a AKRU breaker, we'd check the fuse, tell it we want a Farage Shawmut, amp trap, AB4Q, 1600 amp, and now it will integrate the fuse in all our arc flash and protective device calculations. Same with motor overload. If this was a molded case breaker and we had a GE CR124Y fast fuse, it would automatically integrate that with the motor circuit protector or thermal magnetic breaker. So I'm going to say OK, and there's our unit. Now obviously we don't want to go through that process for each and every breaker on here, and since most of these are going to be the same type of breaker, maybe just a little bit smaller, what we simply do is right mouse click, context sensitive menu, copy, our mouse stays in the middle of the screen, right mouse click, paste, and there's another AKR50. We probably need to make this an AKR30. It's probably a smaller feeder breaker, so we just change this to AKR30. We change our sensor to 800 amps, our plug to 800. Our short circuit rating changes. Our phase trip settings probably change slightly, and there's our unit. Now obviously we still don't want to do that for each one, so we just right mouse click copy, left mouse click press slide release, right mouse click paste, and there's an entire switchgear lineup in 2 mouse clicks.